So yeah, this is going live right now. Cool. So hello, I'm David. I work remotely for Ahrefs. I'm currently based in Barcelona. My currently work is maintaining the design system. I'm working on Style PPX and Server Reason React, those two projects I created a while ago. I'm running emelletv, and I welcome everybody on the chat and everybody on the YouTube video. Thanks for being here. emelletv is a talk show where we bring great developers to talk about OCaml, ReScript, and Reason ecosystems. And we try to have fun with Hindley Miller, ask a few questions, and meet the developers behind those great languages and tools that we use day to day, or we wish that we use day to day, but we finally can meet them in person. So follow us on Twitch, or to follow the stream on Twitter, where we announce the new guests and everything. But today is a super special guest. I had the pleasure to meet him, not in person, in the last ICFP. He ran the keynote, and he ran a workshop as well, and was fantastic. I hope it could be the same level. So let's meet Casey, and I'm not going to try to pronounce his surname. So he's on the show today with us. Welcome, Casey.
Hey, Dave. How are you doing?
I'm very good, very good. Super happy to have you here. I think you are kind of like a face of OCaml. So happy to have you. Just steal you 1 hour of your time to ask a few things. So
very, very happy to be here. Yeah, thanks for inviting me.
Yeah, thanks. So the first kind of questions would be more to meet you, or know where you're coming from. Before we were talking about that you now are CTO of Tarides. So the first question is: do you see yourself as a programmer?
That's an interesting question. I think yes, I do see myself as a programmer. I think I wouldn't see myself as a software developer, perhaps.
Okay.
But I use programs to explore the boundaries of how we should write programs, right? So I mostly write programs to break programs. This is like pushing the boundaries and sort of seeing, hey, where does this fail and how can I fix that, right? So that's the sort of programs that I'm writing mostly. Yes, so I would call myself a programmer.
Okay. That's a good one. That's a good one. So yeah, you are a CTO of Tarides, but I think your resume is very hard to summarize. You work for the IT team Andhras. I think I pronounced it correctly. So university in India. You work at OCaml Pro. You before were on Cambridge University. So your trajectory is not small, and I think you have always been. Which is very good, but you always has been related, or at least working with, which is more impressive even, with OCaml. So I think the first kind of like question is like, why OCaml? How did you arrive to OCaml at the beginning?
I can explain how this worked out. Yeah, it's a funny story actually. So I finished my undergraduate education in India, and then I went for a PhD. So I met this wonderful professor who said, hey, do you want to do a PhD with me? Because I have some funding. And you seem to be aware of this thing called Haskell. And I was.
Okay.
I had played around with Haskell for a little bit. And he said, you're going to work on this thing called standard ML, which I had no idea of, right? So it turns out the professor whom I talked to was Suresh Jagannathan. So he's one of the developers of the Milton Standard ML compiler. And the project that he wanted me to work on was a parallel version of the Milton Standard ML compiler. So
Okay.
Milton is still one of the best whole program optimizing compiler. It produces performant code that is much better than what OCaml would, because it does whole program compilation. There are lots of nice parts to it. And just like OCaml, it was single-threaded. So
Okay.
during my first half of my PhD, I ended up building a parallel garbage collector for StandML.
No way.
And this was, I had no idea what I was getting into, right? I was like, hey, let me just do this. And I was like, hey, now you need to build this garbage collector. I don't know what garbage collectors are, so let me go find out.
Okay.
So I spent, it was a learning experience. I spent a lot of time learning about garbage collectors and what they should do, what a good parallel functional program should do, and so on.
Okay.
But I did this work for a number of years, and at the end of it, I sort of switched to distributed systems and doing some ideas that came from parallelism and concurrency, but doing it in a distributed. Cloud computing was a big thing, and eventual consistency was sort of my gateway drug into distributed systems. And at the end of my PhD, I sort of decided, hey, I did this garbage collection hacking for a while. I'm going to stop doing that and go do something else. So I went to this conference, ICFP or PLDI, back in the day, and I saw this guy who was very excitedly talking about OCaml and how it should be parallel and so on. And I just bumped into this guy and said, "Hey, I'm working on this parallel functional language, right?" And he said, "We should talk, right? And if you ever want to sort of do this sort of thing, you should ping me." And that happened to be Anil, right?
Okay.
So Anil Madhav Reddy, I didn't know him. I just ran into him at a conference, and yeah, so I was. And that's it. That interaction happened, and I sort of went away. And when I was finishing my PhD, my wife and I wanted to move to the UK, and we were like, "Hey, I know this person from Cambridge." So I wrote to him, and he said, "Hey, do you want to work on parallel OCaml?" And I said, "Okay." I think I've done something similar earlier. So that was the first
and that
time.
is what year is that? Because that shouldn't be very, very far away, or it is.
That's 2013 is when I finished my PhD, and then 2014 I joined OCaml Labs as a postdoc, right? So I was after a PhD, you sort of spend some time doing even more work, which is what I got into. But it was wonderful, right? So I met a bunch of cool people. We all worked on this thing together. I learned so much, right? So I had done this thing previously, so I knew what I shouldn't do. So it was like taking those ideas and doing it in OCaml, and that's how I got into OCaml. I didn't write a single OCaml program before I started hacking on the runtime. So
Okay, that's like, yeah, that's hard to believe. That's hard to believe. Nice. So you have been thinking about parallel programming for 10 years.
Yeah, 15.
Did you stop at some point? Did you say that's a problem worth stop thinking?
Yeah. I after a few years of hacking on the runtime, I was like sick of doing this, right? I was like concurrency bugs all around, and I'm like, why am I doing this? I'm staying up all night and I'm doing this. I should be doing something better. So this was, it was quite challenging, right? So, and the thing that I observed is that similar problems also come up in distributed systems when you have weaker consistency models, like eventual consistency. You want to geo-replicate your data, and then you want to access them at the same time. This was before Spanner and all of these consistent geo-replicated systems came on the market, right? So this was still the Wild West. So some of the ideas that I had built up about programming models for concurrent programming were much more applicable in distributed systems. So I ended up shifting there. I still work on distributed systems, so that's my other hat. So yeah, so I've always kept in touch with distributed systems, but stopping working on functional programming and parallelism is what got me there. Actually, my first paper on distributed systems was a purely functional data structure written in Haskell that sort of solves a particular problem on top of this distributed database called Cassandra. So it was It was like a continual thing that happened from functional programming to distributed systems, then do functional programming, then do distributed systems. Yeah, it's been quite rewarding doing
Okay,
that.
yeah, that sounds very complex. Need to say that.
It's not.
But yeah, as often these things sound very far. Talking about complexity, for the people who are using OCaml as a users and have stuff in production or whatever, it's hard to imagine sometimes how much effort is to create a feature in the language, right? If you have some experience in university or even in your weekends or whatever to create a compiler, that your compiler from one weekend is very small. Like adding a feature might be just syntax, maybe some representation, and maybe some runtime, or not even that. But OCaml seems that things are taken very very seriously, and there's a lot of work. How much work is that? I think that's kind of one question, and the other question is more like, usually when if I need to explain to my family what do I do or something, it's very hard for me to use analogies because I always use the Formula One analogy. I do the engine, I do the front end part, so I do more like kind of the outside of the car. What would be a good analogy for the compiler itself for a developer? I know
I
it's a long
see.
question, but yeah.
I think I can address the first part, which is, I mean, how much effort is it to? I mean, I'm sort of rephrasing your question, but
Mm-hmm.
I mean, it seems hard to get into adding a feature into compiler like OCaml, and how much effort is it? Right?
Mm-hmm.
I would say OCaml is just another software engineering project, right? So the bar to entry, we are actively trying to lower the bar to entry.
Mm-hmm.
Uh, there are lots of easy things that one can do in order to contribute to the compiler. So
Okay.
one thing that I learned while I was at Cambridge is Jeremy Allop and Leo White, who were at Cambridge University back then, who
Mm-hmm.
are also
Okay.
contributors to the OCaml. I mean, they are core maintainers of OCaml, but they also ran this wonderful thing called compiler hacking sessions
Okay.
um, in OCaml, where people who probably know a little bit of OCaml just gathered around for an evening of pizza and some like soft drinks, and then
Okay.
they would give you a bunch of easy entry points into the compiler, right? They would say, hey, here's a thing that needs to be fixed, and this is exactly what you need to do. And once you do that, you would actually be, I mean, it's surprising, but making those contributions, um, people who have sort of showed up for the first time have made contributions to the compiler,
Right.
right? So these are, so the way I would sort of imagine the compiler is, I mean, making these small contributions is sort of a way by which you understand how the politics of contributing to the compiler works,
Mm-hmm.
and then you can sort of think about the larger features, right? Um, OCaml is a long-running software project, right? It's just a well thought out, very performant project with very high standards, which is what it should be for a language.
Right.
So if you want an analogy, I don't know, if you imagine like a well-built home, and then
Mm-hmm.
you want to do a little bit of work, maybe change a tap or something, that you can do, right? That you can learn. You know how to change a tap. You just go in and change a tap, right? Those sort of things are quite easy. But if you want to redo your kitchen, for example, right, that
Okay.
takes a lot of time, and you have to. I mean, it's quite disruptive in how it works, right? So this is the Multicore project is probably something like ripping all of the plumbing out and then redoing the plumbing for the entire house,
Okay.
right? So, but I would say OCaml compiler is itself like a really, it's just an ordinary project, and I really want to make it easy for people to start contributing to OCaml. Um, so just to mention this, in the Taradis UK office, we have restarted the compiler hacking
Yep.
sessions. So if
I saw
someone
it.
is interested, they can just show up, and people are there who know how to contribute to the compiler, and they have a list of issues, and they will guide you into making your first contribution. Right? So it's very easy. I
Yeah,
don't.
that
I
sounds
mean,
very
I'm not
easy.
kidding.
That sounds compelling. Yeah, yeah, that sounds very compelling. I was thinking, yeah, what sort of issues? But yeah, Yeah. Like recently, I complained back in the days that we don't have, OCaml, kind of a compiler manual. That I read the F# compiler manual and I thought, I wish, blah, blah, blah. And then someone from Taridis was working on that this last week. So I see a lot of movement in OCaml. One of the things that I'm seeing more from the outside as well is the effort on documentation. So I think we don't want to be the community of things are hard to document or things are undocumented. And now every project that comes from the platform, let's say, like the whole OCaml kind of like core, more than core, has been very well documented, very good tested, and even in real cases. So that's a big change. What other changes can we expect for OCaml 5 and furthermore?
I think that's a quite a broad question. So let me try to answer it perhaps with the focus primarily on what Therides is doing in terms of the community work. I think that's probably something that might interest you. And essentially, OCaml is a very nice language, right? So the core of the language is quite nice. The platform tools have been improving tremendously. So the focus in the short term is going to be making sure that the platform tooling for the documentation, the build system, the package management, right, and the entry barrier into OCaml are all reduced, right? So you get wonderful tooling. You make it easy for people to get into OCaml, and they can be productive very soon, right? That's the sort of thing that we are focusing on right now around the compiler itself, right? On the compiler, I would say we are in a period of sort of stabilization. So OCaml 5 landed, and what has happened now is it landed where we had deliberately not implemented certain features that were in OCaml 4. Right. So, I mean, I can give you examples. One is statman-prof, right? So, statman-prof is this statistical memory profiler that's been very useful for debugging memory leaks and essentially memory usage in your programs. So that particular tool has been sort of not implemented in OCaml 5 because it wasn't clear to us how to do that in such a way that it made sense with multiple domains. Domains are our units of parallelism, right? So now, once the initial barrier where the OCaml Multicore features have been upstreamed to OCaml 5, what we've been doing is we are now making sure that all of the tools that we had broken or not implemented are being implemented. The other one is good one is compaction. So OCaml had gc.compact. It also used to compact heap when the heap usage increased a lot, and there are some internal settings which automatically triggers compaction. There is no compaction now in OCaml 5, right?
All right.
We are putting it back.
Didn't know. These are nice.
You wouldn't notice because the multicore allocator happens to be quite efficient. So if you are not running programs that use a lot of memory and then want to throw them away, you wouldn't notice that you're losing a compactor. But if you do have programs where you do a lot of initialization, you end up with a whole lot of memory, and then you want to say, hey, I'm done with all of this, I just want to throw them away, and then go into a steady state, you won't throw them away at all, right? You would hold on to the memory all the way until the end of the program. So this is where compaction comes in. It's really interesting that compaction is the only place where OCaml releases memory back to the operating system. So it ends up allocating. It might do a GC, but it doesn't return any of the pages back to the OS, right? Unless you do a gc.compact. So now in OCaml 5, it sort of uses a lot of memory, but then it never gives it back.
Right.
We are very close to putting it back. So we have prototype which works. So stepping back, right? So essentially, what is happening now is a period of consolidation where we are helping OCaml 5 reach a steady state where it was as good as OCaml 4 for the legacy programs in terms of both features as well as performance, right?
Right.
And then we can move forward.
Right. Perfect. Yeah. Yeah. That makes sense. I think that's a message that I have been hearing all along. The other thing that is interesting is that OCaml has this kind of, I think, uniqueness of other languages copy some of the features that OCaml has. And it's not one language, it's not two languages. It's more like there's a certain languages that are copying functional programming paradigms, which they tend to be born, or at least from my experience, from OCaml. But there are other languages like Rescript or Reason or even F sharp that they clone the language. They fork kind of maybe not technically the code itself, or they started, doesn't matter,
Mhm.
but they kind of like clone the philosophy behind the language.
Mhm.
Why do you
Mhm.
think? Why do you think that happens?
That's a really good question. I think OCaml's core um, is well thought out, right? OCaml is one of those languages. I haven't worked on too many languages, but of the languages that I've worked on, OCaml is perhaps the most conservative in terms of letting features in,
Right.
right? So it had a very small core, which was known to work. It was very practical, right? It was always started with saying, "Hey, I want to build something for real systems, for real people who build real things," right?
Mm-hmm.
And then it slowly accumulated features, which for which there was always a pull, right? And then it accumulated these features in such a way that it never compromised its core, right?
Okay.
So the set of features that you have in OCaml work well together, and this is a good starting point for a language that needs to um, grow, right? Um, you can program. I mean, OCaml modules are wonderful things, and you can program in the large. So I
Mm-hmm.
think OCaml has this very nice minimal core, right? It doesn't have too many bells and whistles, which is one of the things that I like about the language, right?
Right.
It's quite compact, to be honest, and it makes a nice starting point for if you want to design your own thing, you should start with something like OCaml, and then add the
Makes
fancy
sense.
thing that you want on top.
That makes sense. That makes sense. I think that's kind of like more people done that. So yeah, makes total sense. You mentioned that Camel, the Camel compiler itself is very pragmatic when adding things. And I think one of the other kind of balances is like stability. A program from 402, which might be 8, 11 years old. I don't know exactly, but kind of like a program from 10 years ago, it's going to compile fine, right? I think that's kind of like a feature.
That's
Uh,
wonderful, isn't it?
that's very wonderful. That's very wonderful. There's one thing that the kind of like the global developer pool, kind of like the community in general, they don't appreciate much, in the sense of now seems that everything needs to be rewritten over and over, or things need to get into the trash. Um, things, I don't know. I'm not gonna get into some details, but maybe like all the people who wants to write everything in Rust, or people who wants to migrate from your monolith. I'm talking mostly about web, but they want to throw away the monolith and go to microservices. So kind of like rewrite it from scratch. OCaml has this feature of stability, which I think it's a feature, but as well sometimes might feel like is a baggage. So can be considered a bug where why do you want to support a program from 10 years ago? Can you give me kind of like your perspective on that?
I think software is meant to be. I mean, I would rather take software that's stable and I don't need to change than things that I need to. I mean, refactor and make it work with the latest thing over and over again. I mean, it will keep me busy. If my company uses such a language, I mean, I will have employment, right? I just need to keep doing this. With OCaml, I think it's one of the strengths of OCaml, right? If you look at, um, I mean, OCaml has been used to build these generational tools, right? So tools that sort of um, are quite critical, right? Things like the cock proof assistant, right? So which is like used for formula verification. I mean, it's lots of lines of code, right? It's a massive piece of software. But the correctness of the cock proof assistant is very important because it also feeds into the correctness of the code that you prove.
Right.
So you want the software to not change often, right? You don't want,
Right.
I mean, they're rightly very conservative, and OCaml is like a good language for them. And yeah, so I don't know. I don't work in web. Maybe you can explain
Right.
why there's this need to sort of rewrite things often, right? There must be some reason. OCaml is fairly good. If you write code in OCaml today, I mean, you can be fairly sure that 10 years later it would still run. It would still run with similar, I mean, memory, time, performance requirements that you might have. It's a
Right.
good thing, right? Why wouldn't you want that?
It's definitely a good thing. Yeah, I think kind of the explanation goes along like there are, of course, to choose a language. I think there's a lot of factors. Stability might be one of them. Performance will be the other one. But yeah, I think people run like kind of like want to run very fast as the startup has been created very soon, or people think about like one feature that even though that you might be in a big company, you want to get it very very fast. Languages that get you very very fast are obviously like they compromise like the flexibility, they compromise stability and correctness or safety. So those languages are always preferred because they are gonna be thrown away, kind of on purpose. I think that's kind of like why I have seen in the past, like my experience, like the front end goes very fast, the back end is more conservative. It's kind of chooses more wisely the language, or even like where has been deployed. Now I don't know, the kind of like infrastructure have changed a lot, so you can deploy very close to the user. That was not true in the past. So like there are all these kind of like variables that affect maybe your engineering team. So I think that's kind of like the counterpoint for being fast. But yeah. One thing that you didn't explain a lot is that why OCaml. Like I think you fall into standard ML because Haskell. You got into Multicore because Anil ran into you. What OCaml? What do you like about OCaml? Like the as a user.
It's a really good question. So I ended up working on StandML. Milton is a wonderful compiler, but it is a very complex compiler. So you write some code, and it would make all of these inlining decisions, right? It's a whole program compiler. A whole program compiler takes all of the source files and then compiles them together, right? So
Okay.
so that it produces. So it does it every time, right? It is very much different from OCaml, how you compile it module by module. So it takes all of the code together. It can when you have all of the code together, you can make lots of these nice inlining decisions, right? You just say, hey,
Okay.
I'm going to inline this function into that, and the executable that the final executable that you produce is going to be really fast. But one of the downsides of that is it's really hard for predicting performance, right?
Okay.
So there are lots of these heuristics that go on internally, when to inline and when not to inline and so on. So one of the things that I really struggle with is I have some source code. I'm going to put some minor optimizations, and then I want this optimization to reflect in my final executable, right? I just want to
Right.
decompile my executable. I want to see good performance. This is
Right.
very, very, very hard in
Okay.
Milton, right? Then I spent some time at Microsoft Research, Cambridge, where I work with Simon Marlowe and Simon Payton Jones as an intern, working on bits of the GHC runtime. GHC is wonderful, right? So the runtime is excellent. I learned so much hacking on it. So just to give a little bit of what I did, I implemented lightweight threading, like fibers,
Okay.
in GHC. At the language level, we implemented something like delimited continuations, right? Not true delimited continuations, but something at the language level. But I was
Okay.
trying to do this for ease of use. So I did all of this work in 2.5 months or something, and then I had 2 weeks where I could run some programs, get some benchmarks, write a report, right, for the
Okay.
internship. I wrote some program, and then I was like, this program is not running as I expected it to be. Why is this, right? Then I was introduced to all this thing about space leaks and strictness annotations, and I was like,
Okay. I don't
what
know
is
what
all this?
those are.
I wrote my so essentially Haskell is a lazy language, right? So
Yep.
you so you so the way you sort of imagine your program executing is very different. The mental model of how you imagine your program executing is quite different.
Okay.
So everything happens through graph reduction. So when you call a function, it's not evaluated at the point of call, right? You
Right.
sort of build this thing, and which is on demand evaluated. This is very hard to. I found it very hard to reconcile
Okay.
when I'm writing high performance code, right? I'm going to call this function. So you can't do things like I'm going to take a lock, I'm going to call this function, which is going to do add one to some other result, right? And then I'm going to release this lock. Now, the problem is in a strict language, you know that the value has been evaluated. So you add one to it. The only
Right.
computation is adding one. But in Haskell, this could be arbitrary computation, right?
I
This
see.
value might just be something very big. So
Right.
now you have to be really careful because you're taking a lock. You're doing
Right.
something which you think was really small, but it could be quite large, right?
Okay.
And
I
this is
think
the reason
it's the first
why,
time. I think it's the first time that laziness of Haskell has been explained to me properly. Well, it's each value it's lazy, so
yeah,
it can carry all the memory on the wall. Or can
yeah,
carry
yeah, it
everything.
can do
Okay.
anything, right? And the
Right.
thing is, this is quite contradictory to I think how I was taught, right? So parallel programming and so on. You make your critical sections very small.
Okay.
The thing is, you can't, right? And the thing is, the clever bit is that is the reason why Haskell has STMs. It doesn't do locks and unlocks.
Right.
It sort of lifts the level of abstraction up. There are all these things going on, and then I tried to dig in, and I was like, you use strictness annotation here. You make this one strict. You can optionally make things strict in Haskell,
Okay.
right? I was like, I just don't know. I'm not smart enough to optimize this program,
Right.
right? I was just trying to do some benchmark and so on, and it was like not for me, right? So that
Right.
writing high performance Haskell code was not something that I am used to. So then I came to OCaml, right? OCaml compiler is surprisingly simple. You write some code, it'll produce some assembly, right? And you're like, hey, this looks very much like the code that I wrote. And then you change a little bit at the source level, right? You see corresponding change in the generated assembly.
Okay.
This is exactly what I want. So this performance predictability is wonderful, right? This OCaml thing is like coming from a very complicated compiler and a very complicated runtime system in Haskell. OCaml was like a breath of fresh air for me.
Right.
It was like so simple. Um, I mean, it's surprising how efficient it is given the simplicity of the compiler.
Right.
Right? It doesn't do much, but the runtime system is very nice, and this uniform value representation makes
Right.
things much easier to reason about. As someone who cares about performance, it is it's a nice language where you can start with some high level logic, and you can put in say 1 hour of work trying to optimize your program, and then you will get commensurate results, right? So this is very pleasant. This is not something that you
Yeah,
get in
I
other
experienced that.
languages.
Yeah. I have the same experience. Yeah, I need to say that I live that. Yeah. Yeah. That I think that's a very kind of like profound reason to choose a language. But yeah, yeah, very good one for sure.
Yeah, it's
Um,
wonderful. It's a nice language, but it has this. Yeah, it's just completely changed how I sort of looked at high performance code. Right, you can
right.
write this in this high level thing, and you get nice code out, which is great.
That's very good. That's very cool. One of the projects that you have been very involved is Multicore. I think that's kind of like if you're not the face of OCaml, you're the face of Multicore. Like I'm sorry, I don't do I don't do the titles. That's how those are done. So Multicore. First of all, what's Multicore? What's Multicore? Well, like kind of like from the kind of operating system logic. what's Multicore.
Okay, so I should say that I may happen to be the face of OCaml, but Multicore is like lots and lots of people's
That's
work.
true. That's true. That's true.
But let's sort of step back, right? So why Multicore? So you understand hardware, right? A little bit. So let's say you have a machine which has really fast code, right? And I don't know. Back in when I was young, these cores got faster and faster, right? So you could buy a machine. You would just then wait for 2
only
years.
one core. So like only one core. Yeah. Like every year was like Intel, blah 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 blah. Super excited, expensive but cool. Yep.
Yeah. So the thing is, I've heard this thing where you can either put in effort to optimize your program, or just wait for some time, buy a faster machine, and run your programs faster. Right? This is like make programs faster by doing nothing.
Exactly.
Is like a wonderful thing. It went for a number of years, right? And then we hit various performance scaling bottlenecks, and we started having many cores on a single chip, right?
Right.
This also makes sense because when it's much easier to replicate a complex logic multiple times, it turns out.
Right.
And we've had multicores for a long time, right? And when I started my PhD, people were talking about in like 10 years we'll have thousands of cores on a commodity hardware.
Right.
That didn't happen, but it's still like a fairly decent number of cores, right, on high performance machines. So if you want your programs to take advantage of all of the cores, you can spawn multiple processes at the operating system level. Operating systems are very good, right? So you have a process, you create another process. The operating system ensures that the two processes run on two different cores. This is great. This is wonderful. So you can write exploit the available cores using this. But it turns out that this can only go so far because of how the process system works and what you can share and not share between multiple processes and how you communicate between these processes. There are lots of applications where you want to take advantage of multiple cores from within a given program. Right? That's the thing. It's not new, right? So multi-core languages have been around for ages. So certainly multi-core OCaml was not the first one, and I'm very happy it wasn't the first one because we could actually learn from all of this experience, right?
Okay.
So essentially, what we were trying to do with multi-core is, hey, I have this OCaml program. It can run very fast on like a single core. So now, if I want to take advantage of additional cores, I don't want to compromise my single core performance, but I still want to make it take advantage of all of the available cores. Right? This is what the multi-core tries to do at the highest level.
Right. Right. That's a good explanation. And kind of like the question is that like the fact that you didn't want to compromise performance of single core, that effort was gigantic. If you, I haven't looked very deep into all the pull requests, all the issues, but the level of detail of each pull request has been absurd. Like from the outside, has been absurd. Why that happens? Like if theoretically there are like two processes, why, like what are the real reasons for that?
I think it's a wonderful question, right? So I can, I didn't realize this. If I had the foresight, I would have done this very differently.
Okay.
But the thing is, when I was hacking on my own compiler during my PhD, right, I could do whatever I wanted. So I essentially, I didn't care about single core performance. I just wanted multi-core performance.
Right.
So we got this multi-core standard ML compiler running on 800 core. There used to be this machine from Azul called Vega 3, which had 800 cores, right? 864 cores, out of which you can use some 832 or something. We were able to get this thing to scale on 832 cores, right?
Right.
That was massive. But I did some horrible things for the sequential thing to get it to work.
Okay.
But then I mean, coming to a real language like OCaml, right? There are real users who care about performance, right? And short answer to that question is, even when you provide the multi-core support, 90% of the programs, maybe 95% of the programs are still going to be sequential,
Yep.
right? Why would I want, I
Yeah.
mean, with multi-core, you just get lots and lots of challenges, right? All of the usual parallel programming challenges. So this is quite complex, right? So if you want to have multi-core support in a garbage collected language, you want to do a lot of work with the garbage collected.
Mm-hmm.
And one of the ways you can reconcile and get a sequential performance is have two different GCs, right?
Right.
One which is for sequential programs, and another when you choose parallel programs.
Right.
But I mean, this is a huge maintenance burden. OCaml is run with a bunch of volunteers, right? And having two different runtimes would just make it twice as hard for the maintainers, right? So magically, we don't have twice as many maintainers just because some feature was
Right.
added. So my idea was that I want this multi-core feature in, but I don't ever want to compromise sequential performance, because most of my programs are going to remain sequential. I don't write parallel programs all the time. I write a lot of sequential programs, right?
Right.
So that was the reason to
Right.
ensure that we wanted to preserve sequential performance.
Right. That makes sense. So does multicore enable like these 5% that you mentioned, that if, imagine if we were working in a parallel program, uh, is right now Command Multicore would enable those use cases that wouldn't be possible before.
Yeah,
Have you
exactly.
have you
So
seen any use case already implemented?
yeah, so there was some. I mean, obviously, we did a bunch of work to test the multicore ourselves,
Right.
but I wouldn't particularly call that a use case. But externally, Tezos had this um, ZK rollups where apparently
Right.
they had these computations where it's embarrassingly parallel. Essentially, you want to do some operations, but you can split it up such that there is very little dependence between these operations
Mm-hmm.
that can be run in parallel. So they had great success using multicore
Okay.
to parallelize this. Um, I think I think the feedback was that it was very easy to get started and it just worked. Um, that's a good thing to hear. Um,
Nice.
I mean, it's
Nice.
still early days. I think people are still um, testing multicore out.
Yeah.
I would say.
Yeah.
So I'm hopeful that there are going to be many more cases where we'll see large successes, but early days.
Right. That's kind of curious because, like, if I'm a user of the language, I might not enjoy multicore. I might do a script to test multicore, but because I run the language through a framework, or I run the language
Mm.
through many, like I have like kind of like a layer on top. I might just not enjoy multicore right now, like today, in the same sense as in 1 year, when all these tools are migrate or take advantage of, yeah, like anything that can be parallelized. So yeah, that's a good point. That's a good point for sure. uh yeah, and how's the adoption going? Have you seen, apart from Tezos, many people trying to do more things on the parallel side?
I think there's a lot of research efforts, right? So these are people who've in universities, right? So they're sort of pushing the boundaries of what is possible with parallel programming. One of the things that we've done with the Multicore OCaml project is from day one, it has been open source. So it's always been out there and for people to try.
Hmm.
And academics end up, and academics like OCaml, and it's a language which supports Multicore. So there's been a bunch of success without us actually interacting with any of them. And there's like tons of uses of Multicore. I wouldn't call it in the wild, but it's still within university.
Okay.
But there's like lots and lots of use cases. So one thing I should say is in Multicore, right, we actually bring in two features. I only talked about one of them, which is parallelism, which is
Right.
taking advantage of multiple cores. But OCaml 5 brings in basically two features. One is parallelism, other is concurrency. So when I say parallelism, it's like simultaneous execution of computations on two different cores. So concurrency is when you have multiple computations, but you run it one after the other, right?
Right.
So they might time share the same core, for example, right? And typical place where concurrency is used in OCaml is for asynchronous I/O, right? So if you look at things like LWT and async, they sort of have multiple I/O operations that you want to do, and then you can sort of simulate concurrent threads using these monadic concurrency libraries. Essentially, they're not monads, but they sort of have the semblance of a monad, but you're essentially doing callback-oriented programming, right?
Right.
And the trouble with callback-oriented programming is that you're sort of you have your own program stack, the regular synchronous calls, and then you also have this other world where you're sort of programming
Right.
with asynchronous computations. So this is like the usual color problem, right? You have this async world and the sync world, and it's extremely hard to sort of go back and forth between
Right.
these worlds.
Right.
And
So
OCaml has a color problem. Yeah, go ahead.
one thing to interrupt. People from LWT or even other like even async, they try to fix it with syntactic level, like try to like it kind of like lie to you a little bit to the user, where you don't differentiate the synchronicity from the synchronicity. You would add maybe like a let operator or maybe a PPX or something like that. That's kind of, do you see it like something like a patch? Or do you see something that it's improvement, or do you think that really OCaml 5 or OCaml Multicore should remove that direct style versus the asynchronous style in kind of like one?
I think that's a really good question. So I should say that this I was skeptical of
Okay.
the syntactic let operators when it came out. So I taught my students monads. This was my
Right.
first year of teaching OCaml to them. I finished my first lecture, and the second lecture I come in and teach some further monads. They were like, "We don't understand what monads are."
Right.
Right? I just don't get the intuition. I thought about this all day. I just don't have an intuition for what they are.
Right.
So you have to explain it again. So I tried to explain it again. I don't know how. Probably they stopped asking, right? They're like, "Hey, this person doesn't know what monads are. We shouldn't probably poke him any further." Uh, so yeah, that was the first year, and the second
Okay.
year I actually taught it with these let operators. I explained what monads are, but then I said, "Hey, you can also write it this way, where you sort of hide what is going on, right?" And then everyone got it.
Right.
It's incredibly surprising.
Right.
I was
Well,
I was
that's very
surprised, right?
interesting.
So
Okay.
I had zero expectation that anything would change. That was not my intention, right? I just wanted to play around with the syntactic thing. It just completely changed
Wow.
how people perceived these monadic operators to be. Once you hide this thing, right, they're just effects, right? Just like
Right.
how you can have arbitrary state, you have concurrency now. You have some thing threaded through. I mean, they just got it.
Right.
But to answer your original question, right? So this still doesn't solve this color problem, right? You still have these two colors,
Right.
right?
Yeah.
Syntactically, they're made to look nicer, but the color problem still exists.
Right. So, like, I think, just to rephrase, at some point you join asynchronicity, you can only go back calling asynchronous, like going through the path to asynchronicity. If you want, you need to say, wait for this value to appear. Usually when you introduce asynchronicity, it kind of like spreads across your program.
Yeah.
Go on, sorry.
So the thing is, the way I sort of imagine this is, you have two program stacks essentially, right? So
Okay.
you have your usual call stack, which I would sort of draw a vertical line, and then you have this horizontal call stack, right? Which is your callback chain, right? So it's essentially, I mean, you are writing an explicit continuation passing style. I'm doing this, and then I'm doing that one, and then I'm doing that one, and then I'm doing that one. So now the problem is that this vertical stack that's your program stack, right? You throw an exception, that's the stack your exceptions are going to go into. This horizontal thing, which is your callback chain, is like your program tools are not aware of it, right?
Right.
So, I mean, this is the reason why you won't get a good backtraces for LWT or async
Right.
programs. You can't use exceptions. You have to sort of do something else, right? And I mean, ordinary things. I mean, in OCaml, we don't have higher kind of types, so you can't use like map that works over both the pure computation and lots of these nasty things come over, right? So I think erasing this color problem was one of the motivations as well, right,
Right.
for us. So when we were designing Multicore, we wanted to make sure that we had some notion of lightweight threads in the language, right? This was, I mean, I've always StandML had lightweight threads, right? And GHC had lightweight threads. So I've been working with these languages for so long, and they just seemed natural. Go had come out, and people did not. Yeah, I mean, people accepted lightweight threads as like a normal thing, and lightweight threads are back in Java, right? So Java now has virtual threads. I mean, they kicked out green threads from Java back in the late 90s, and then they're back now. So, I mean, we were always convinced that we needed lightweight threading in the language if you want to exploit parallelism properly. You don't want to program directly with hardware threads, right? Because
Right.
hardware threads are resources. So you wanted a layer of abstraction where you have language level threads, and that is concurrency for us, and that is what erases this color problem.
Right.
Right. So that's the other big feature that OCaml 5 has.
Right. Yeah, that's where my head is at when I think about effects. I think that's kind of like the goal or kind of the feature that I see myself as a user using it more, or think about using it more. I think about concurrency. Effects are kind of like in a weird state now. You can use them, but it's better to use AIO or any sort of library. I think the new one is called Oslo. I think I just mentioned because the author it was on the chat. Those libraries like abstract you from the fibers, so extract you from the concurrency. People have been talking about algebraic effects, uh, for me at least on the academia for a very long time, and OCaml seems to be the first language that actually implements the beginning of it. What are the next steps for effects?
So that's a good question. So I should say that you can view it in different ways, right? So the way we sort of maybe taking a step back is useful, right? So
Yep.
when we started designing Multicore OCaml, we knew we wanted some feature for parallelism and we wanted some feature for concurrency, right? We did not say, hey, I wanted algebraic effect handlers, right?
Okay.
That was not our goal. Our goal was, I want a way to express concurrency in a language, like true concurrency, right? Not using monadic ones. I want a way to express concurrency. And I mean, coming from academia and working in languages like StandML and Haskell and so on, I mean, I was very familiar with continuations, like language level manifestation of some suspended computation, right? And our idea was that we will introduce this into the language just so that you can build concurrency libraries on top, right? So you wouldn't implement them in the runtime just like Go does, but we can implement them as libraries in OCaml, right? That was our goal. And on this, I mean, at this juncture, there are lots of different ways to introduce continuations into the language. And this is when we were introduced to effect handlers through this wonderful language called F, right? So Mattia
Right.
Pretnar implemented this language along with Andre Bauer. So they showed us how to implement how to program with effect handlers, right? And then we sort of stole their idea, essentially, right? So
Okay.
it's a wonderful language. It's like, hey, this works nice. And then we took parts of the language and adapted that for OCaml, right?
Right.
And the thing that when I say part, the thing that we didn't bring over is the FX system, right? So what does an FX system let you do? It's like statically check exceptions, right? I throw an exception. Do I have the guarantee that there is always a handler that can handle this exception? This is not what OCaml provides today.
Mm-hmm.
So because effects are similar, you throw an effect, you raise an effect, and you have a handler to it. When you have an effect system, it will ensure that you can't throw an effect without a handler. Such a program would be ill-timed, right? This was actually never our intention, right? We did not aim to bring an effect system into the language at all. Our aim was to just add the concurrency primitive so that you can build things like EIO and Oslo, and domains lib also uses effects underneath.
Mm-hmm.
So the thing is, if you program with any of these libraries, you would not encounter effects at all, right? You wouldn't have to know that it's built over effect handlers. And that's the whole point. Of course, the only thing that you need to remember is you need to wrap this thing with a high level, at the top level run function, right? There should be this run function, just like LWT, right? LWT has this LWT main dot run. I forget what it is. Async also has something similar. You have to do this thing, except that there's nothing else, right? The fact that it uses effects underneath is not your concern as a user.
Right.
You just use the library just like you would use things in Go, right? You just have Go routines, you just use it. Hey, just make sure that there is a top level thing. So this works pretty well, right? Actually, I think people get carried away with this idea that hey, we should have an FX system, right?
Okay.
It would be wonderful, but it's a massive change to the language, right? Because it changes how your types are represented fundamentally, right? So now, if I have my print string function, right? My print string function now, instead of a string to unit, it should say something like string to unit, but performs an IO operation.
Right. Okay.
So this is like my worry here is that it's a massive change at the language level, right? It has to be done in a nice way so that all of your I think the primary concern here is backwards compatibility. If someone tells me, hey, here is a solution that is backwards compatible, that also adds an FX system, you don't have to change anything, right? Some of our users in OCaml have millions of lines of code, right? And I don't want them to change their code, right?
Right.
There should either be an automated tool that says, hey, take this code, move this over with minimal change, or nothing, right? Or don't do anything, your code still works. FX system is a massive change, right? So I think there are other ways to get around this problem of not having an FX system. FX systems are cool, but they're also open research problems, right?
Right.
They're very, very, very new, and you can build a new language with an FX system that just works, but retrofitting that into OCaml is a huge challenge. I think a lot of smart people are working on it. I'm not one of them, so this is just my take on this. But that's the challenge, right? Backwards compatibility is the major challenge.
Right. Yeah. Okay. Yeah, I got your point. Like, it's still surprising that it was not intended. I think that's kind of like the thing that I learned. I learned that today from you. So, that's very interesting. So many people kind of like try ChatGPT with OCaml. I think that's kind of like we must mention AI today because of course like we should put on the title of the stream ML kind of something mid-journey, like something, and then people would join. I would say, oh, it's not machine learning, right? So that's a good hook. So OCaml is like kind of like a niche language. I consider as a niche language if you compare to usage. I think many people is working on changing that, and I think that everybody's happy with that. But these language models, like large language models, are trained with a lot of usage of those languages. So like, they describe, I don't know, Stack Overflow or GitHub or whatever. Have you tried ChatGPT with OCaml? What are the results?
I've been playing around a little bit. I think it's still early days. It's surprising how I don't work in ML. I don't know the heads or tail of ML, right? I haven't taken any ML courses, so all of this is magic to me, right? So I get asked to be on ML conferences because I have ML in my standard ML in my web page, and that's always funny. Not that kind of ML. But the thing is, the thing that I've done with ChatGPT, I mean, I've not spent too much time, is that it gets very quickly to a program that's like 95% right.
Right.
And then there's this 5%, which I think it's just extremely hard for me. Maybe I'm not talented at prompt engineering, just to make it say, hey, you have a bug
Right.
there, right? Run it through the type checker, see what the output is, and then go fix that bug, right? It will tell
Yeah.
you what line the bug is going to be, right? I think having statically typed languages, right, is like a thing, right? So you have this oracle that's sitting somewhere. You generate a program. Hey, it's not right. Run it through this oracle, right? Which will
Right.
tell you whether this program like type checks or not, and then you can feed it back. It's better than Python. You just get some program that just runs syntactically right, and it just runs, and you don't know what it is. At least you have type safety, right? Actually, the thing that I've been trying around, which I've had reasonable success with, is I also work on program verification.
Right.
So write a program, you also write a proof. Type systems in OCaml is also like a simple program verifier, right? So
Okay.
you have this program, you have a type. Type is sort of the if you want to use Curry-Howard isomorphism example, types are like theorems and programs are like proofs,
Right.
right? You have one type, and you can have multiple programs that have the type. So it's like evidence that this particular type has a program. Similar idea is used in Coq, right? So
Okay.
so the thing that I asked ChatGPT to do is write me a program, but also write the proof for it, right?
Okay.
And so the thing is, so the fundamental thing when you use these large language models for programming is that your job becomes rather than programming, you're doing proof checking, right? Proofreading the
Right.
program.
Right.
You have to read the program, and then you have to check whether it's right. And I find reading other people's code much harder than reading my own code, right?
Right.
This is just what I do. I mean, it's a different style. It generates random things, and I have to now work out, right, to see
Right.
whether it's right. I think if you can sort of say, hey, here's a program, but here's also proof, right, that the program is right, and I can run the proof through Coq,
Right.
and then Coq says, okay, the proof is right. You only need to check the spec of the program, right? This is actually very cool. I think some people are actually working on this idea.
Oh, that's very interesting. Nice.
Yeah, but you can easily check this whether it's right or wrong, right? As long as you can read the spec and then say, I have this program, right? And this program has been proved right by ChatGPT, and here's the proof. You run the proof through Coq, and if it says okay, you're done. You don't have to do anything more.
Exactly. Right. Yeah. Well, which brings me to the next question, which is like many people are thinking about that, but I see these tools that we're interacting every day that are very dummy, right? Are like practically as stupid as you could be. So you ask Dune build blah blah blah, blah and Dune is like, no, you didn't specify the module or whatever. And I was like half feeling like if we could glue all together and we could make the compiler is telling me a type error. Can a model suggest me 3 ways of fixing it? Is this something that makes sense in general? Because you mentioned if Coq if ChatGPT can generate the Coq to verify the program, ChatGPT could maybe create the unit test for the program. So it's definitely at some point the prompt engineer would definitely only think about what a product owner or kind of like a manager would think about. Oh, I want this software to do this and that. And the question that I think I have is how OCaml can benefit from that. You mentioned I want a program that can transform a million lines of code and have no regression. That if I need to do that by a PPX or by a string manipulation, that might be very, very hard. But what are the techniques that can make sense in OCaml?
Yeah, I think the question is actually feels like you've thought about this question more than I have, but I will share my initial thoughts on this.
Yeah,
right?
definitely. No worries.
I certainly think that the use cases that you've said, right, which is I have this type error, I want to fix it. What are the possible fixes? This seems like an infinitely useful thing to do, right? So this is like any
Right.
developer experience, which includes like someone like a TA, right? Like a pair programmer who is just sitting next to you and then saying, "Hey, you have this type error. Here are the three things that you can try," right? Um, which is wonderful.
Right.
I think having a type system, static type system, um, makes a lot of things nice because you get a lot of type errors, and there are only few things that can fill the hole that will satisfy the type. It's not like arbitrary large expressions that fill
Right.
this hole, right? There's a lot of work on program synthesis, which try to take advantage of typed holes. So there's this work by Cyrus Omar at University of Michigan,
Okay.
where they've been programming with essentially IDEs where you sort of start writing your partial program, and then you have these holes, and they would be incrementally filled by program synthesis or other sort of tools, right?
Okay.
So this is incredible piece of work, and getting these large language models into this is like another plugin for these tools, right? That's
Right.
how I sort of see it, and there's definitely going to be value, right? There's yeah, I certainly see that the way we write programs, ordinary programs, right, is going to change a lot. The way we sort of develop these is going to change quite a lot in the next few years, right? We just spend too much time writing programs. I think not all programs are fun to write.
Right.
Um,
Yeah. What parts of writing a program you don't like, or like found less satisfied to write? I can say for me, it's parsers, for example. Like a parser is,
I yeah,
it's like, yeah, you need to do it, but I want to work on the, like, what's parts, not on the parser itself. And bugs in the parser are always like a pain. So
I
what
think
what
uh,
what
I
are
think you're
yours?
right. Parsers are terrible. I just don't write parsers. Um, yeah, so I hate parsers. I I think to be honest, I write programs, but I like running them. Um,
Yeah.
so I like to run programs. I write programs for performance, right? And then I run them. I see something, then I use all my tools to make my program go faster. That's the part I most enjoy.
Okay.
Um, and I also enjoy the initial bits of taking a large idea and then transforming it into here are the data types, here are the high level functions, here's the API. I
Right.
don't like the intermediate bits, right? I just don't. I'm like, I've given you what you want, and you just write the rest of it, right?
Right.
I think we should be there, right? So once you write
Yep.
down the data types, right? Data types should inform you what sort of programs can manipulate it. If you have some intelligent way of describing what you want, and you have a set of data types, you have a powerful type system. So I think these should work in combination, right? Um, I mean, somebody will invent this magic tool, but the
Yeah.
one sad thing that I see with all of these AI research for programming is that they're all targeted towards popular languages, Python and
Right.
JavaScript and so on, but not for OCaml. The thing is, OCaml has a static type system. I think if you sort of include it as part of this AI's
Right. The
capabilities,
training.
you
Yeah.
would produce much better program.
Yeah.
But I think, yeah, I mean, naturally, the researchers are going towards where the maximum benefit is. You can generate
Right.
lots of bad Python programs, right? But
Right.
in order to generate OCaml programs which pass the type checker, you need to do a lot of work. I mean, that's what I do most of my time, right? Fighting with the type checker. Um,
Right.
but yeah, but if more people sort of think about, say, generating proper OCaml programs or Rust programs, um, I think
Yeah.
world would be a better place.
Oh, that's a good quote. So yeah, I think we're getting a little bit late, and I think your time is very late. But still, have us. I would spend another hour talking to you, if I could, but without getting you run away. OCaml 5 has been a tremendous amount of work. what are other features that, aside from the runtime, I think you are very runtime focused, and I think I learned that today. What are the features of the language per se that might come into next in OCaml 6? Or I know that there's OCaml 5.1 and all of these, but on next versions.
I'm quite excited about a bunch of features that Jane Street is working on. So one of them is modal types more generally, but stack allocation particularly. So you would you today if you allocate something, it goes in the heap, right? There's a nice way where you can sort of tag objects as being allocated on the stack.
Okay.
Your type system will ensure that your stack allocated objects don't escape the context. You can't just pass a pointer to it outside the calling context. And then this allocation sort of happens on a different memory, right? That works like a stack, but it's not the program stack. Okay. It's like a heap organized just like a stack. It's an area where you would allocate these objects. When the functions return, you can just throw away that memory.
Okay.
Right? It's really cool. It has a bunch of interesting language aspects as well. So once you have these local types, you can use them to get FX safety. You can get 70% of what you want with an FX system in a lightweight fashion, right? Okay. So if you sort of think about, stare at it, it's the same sort of solving the same problem, right? If you sort of think about what exception handlers do, you have a handler, and then you can throw exceptions here, right? You can't throw exceptions underneath or not have a handler and throw an exception.
Right.
This is exactly the problem that local types are also trying to solve. You've allocated an object, and then you have a reference to it. You can't use this reference outside of this point, right?
Right.
That's the same problem, and once you have these local types, you will get 70% of what you want from an FX system.
Right.
And this is backwards compatible, right? You sort of opt into doing this. So I think I'm quite excited about that coming in. There's also a number of other features, longer term, right? So I think one of the features that I quite miss is type classes in Haskell.
Okay.
So modular implicits in OCaml.
Right.
I think it would be very cool. Somebody has to do it.
Somebody have. Yeah, that's perfect.
So
that's perfect.
It's
sorry to interrupt. Like model types, I think I heard two presentations from Dolan explaining model types. I think the last one was from ICFP, and I think I saw one on YouTube like I think 4 years ago from Jane Street. And I wanted to pause for a second before going to modern implicits. Jane Street has been like a big player onto the language, but in a weird relationship. In a weird relationship in the sense of they don't own the language. Usually companies or big companies, I consider Jane Street a good big company. Usually Google owns Go, so they can do whatever they want with Go, or theoretically whatever they want with Go. Or even Rust at the beginning was Mozilla. Like all these companies, Jane Street is more kind of like a colleague rather than a kind of like a parent. How's that affecting the core of OCaml? How's the governance between kind of like a people that come from Cambridge and people who wants to do all sort of academia on top of a language like OCaml, and an industrial user that doesn't own the language?
I think it's a very good question. So, in terms of governance, OCaml is like an open source project that is not owned by any particular entity. There are a set of maintainers, right, who maintain the language, and there are a few Jane Street people who are set of maintainers. I'm one of the maintainers. There are lots of people from INRIA who are maintainers. There are other people who are independent who are also maintainers, and we sort of collectively we don't have a plan. We wouldn't say, hey, we want this feature in and we are going to get it in and this is how it's going to work. We don't have a committee. We don't sort of design by committee and implement it. But as and when features come in, I think the set of maintainers do an extremely good job of making sure that the feature gets in if it's good, right? So that's the way it's sort of viewed. So if you bring in a feature that you can justify that it is a good feature and it benefits the language and the users, then the maintainers are happy to accept it.
Right.
So it doesn't matter if I propose a feature and then I happen to sort of get other maintainers to on board, right? So I have to
Okay.
actually convince everyone that this is a good feature. For Jane Street, I think they've been contributing to the language a lot. They are, they've been a player where they've been using the language, benefiting from the language, but also giving a lot of putting a lot of effort into the language and the ecosystem and so on for long, many number of years, right? They are continuing to do it, and they have a number of experimental features that Jane Street has been internally using and deploying, even, right? So these local types have been deployed within Jane Street's own compiler. I mean, it's OCaml plus extra features.
Right.
I think it's a good thing, right? So the reason why I say this is if somebody comes in and says, "Hey, here's modal types for the language," right? And I have wrote a paper that's been published in ICFP. You have to accept this. I'd be like, I mean, I don't know how it works at scale, right?
Right.
But for Jane Street, now you can say, "Hey, here's a feature that we've tried on like 20 million lines of code, 30 million. I don't know what the number is, right? Thousands of developers use it every day, right? And then we actually know we have empirical evidence, right? And then you make a mistake, you have an option to quickly fix. So Jane Street has its own compiler. It's all in like a single repo, so they can change it, they can deploy the fix, right? It's a very nice testing ground for these features, right? So I think it's I would be more confident of these features coming in after testing than directly these features coming in. We had to do this a lot with OCaml Multicore, right? We had to sort of write papers and have these out for many, many years, and a lot of people had to use it. And I mean, we had to do this work. You still have to do that work, but in addition, validation by like thousands of engineers using the features.
Right. Yeah. There's nothing there.
Basis.
Yeah.
So I think it's a good thing. I think it's like so it's like this feature which has been tested. We now have to work towards upstreaming it and making it available for all of the users outside. I think it's a very good relationship.
Yeah, that's very good. One of the things that I find funny, because I work for Ahrefs and Ahrefs does not have a fork of the compiler, which means there are many companies, not many, but enough to mention that people has a fork of the compiler that they push patches. For example, I know the one that Lexify has. That they have a feature that it's not upstream, and they try to upstream twice, and it's the type representation. And I think time reflection, I think they call it. Well, just like they know, the type that the time at runtime, basically. And I found it always fascinating how both things are true at the same time. So people do enjoy OCaml. They even capable of creating stuff on top of OCaml, but as well, the standard library has like 5 versions of the standard library. The runtime, like AIO, has 3 versions. For me, the fascinating part is like everybody's so capable of creating their own stack or their own the building, right? That I think it's hard for people who are not as expert or not as the level of you are able to understand from the memory until your developers, like entire capability. Do you see this as a barrier for entry? Do you see as I'm new, I just watched this stream, I love OCaml, I'm gonna install OCaml right now, but everybody is talking all the time about model types. Everybody's talking about FX system. Like everybody is 10, like as a newbie, you feel that there's people who are 10 steps ahead of you all the time, right? That you're new and alone.
Yeah, I think two things that you mentioned are a challenge, right? We shouldn't be talking about new fancy features all the time. I think we have to spend time like with the practical stuff, right? We have to see, hey, you wanna build your next company using OCaml. Today it's seen as a risk, right? I think I want to turn this as like an opportunity. And for someone who's like, hey, OCaml seems like a good language. Let me just go in and what are the libraries that are out there? And they would find 5 libraries, right? Which is great. But
Right.
if I just want to build one, I mean, what's the recommended one, right? I think these are problems. There are no easy solutions to this.
Right.
Um, I mean, it's a healthy community. They can build whatever they want, but I think we have to do a little bit more work towards consolidating some of the efforts so that
Right.
if you just want to build your fancy new website using OCaml and JSU and whatnot, here's the stack, right? You just
Right.
go build it. Don't think too much about what it does, right? They shouldn't care about FX systems, and they
Totally.
should, but
Totally.
uh,
Totally. Yeah.
but it's a bit of a challenge, right? So
Yeah.
I think looking always too far ahead would alienate people who just want to use OCaml as a means to an end, right? At the end of the day, languages are just like tools, right? It's what you build with the language that matters.
Right.
And if I'm building a company, I don't care about using OCaml, right? I shouldn't, right? I should care about the business, and
Right.
OCaml should be the right tool for the business, right? That's where we
Yeah.
want
That's
to be,
that's
and
really
we're
good
not there
thought.
yet.
Yeah. Yeah. One of the and I think we're getting very very close to the end. But one of the things that I heard a lot of times talking, Ivan is the creator of Elm, and I think he has a lot of psychology about how the community should grow and should shrink. One of his comments is when you create when you release new version, or when you jump the language forward, there's a lot of like fragmentation. Like by natural, everybody is like,
Mm.
oh, hype, oh, this solved my issue, or I'm gonna build my company or do the library, and then everybody kind of like does the effort, and at some point there's one champion or there's like two champions, and there's like all the kind of like work tends to consolidate, meaning that you would see the YouTube tutorial, the kind of like the course on whatever, the company that succeeds, that uses whatever library, right? And I think that kind of like compression is that I think I got the feeling that it's compressing a little bit OCaml, where
Mhm.
we still talk and dream about the features that might come, but we try to be more pragmatic on what needs to get done rather than dreaming about the next feature. So
I think I agree. I think I like to talk about these forward-looking features, but I mean, most of my day-to-day work is like, hey, let's make OCaml a stable language, right? Let's build the
right,
platform around it. Let's build the community around it. Let's make it a welcoming place for like new users, right? And then let's make it like a thing that people want to build with, and it shouldn't. And OCaml should be the least of their worries, right? They should
right.
be like, hey, let me just use this thing so that I can move fast, right? That's what I do mostly, and I completely agree. That's where we should focus our efforts
Right.
on.
Is that like, because is that the mission of Tarides? Like kind of
Yeah,
because I think you are the CTO, but I think everybody on Tarides is kind of like pushing in the same direction. Um, is that is that true?
yeah. I think our goal is to make sure that OCaml is a wonderful language. It's a wonderful language for building real world software, right?
Right.
It needs to be performant. It needs to, I mean, it needs to be expressive. And if that requires certain language features, we will add it in. The platform tooling story is solid, so that if you want to build stuff with OCaml, you should be able to without trouble, right? I mean, this includes all of the tools, right? Dune and OCaml format and ODoc and all of these things
Right.
should be good. And that's the sort of focus that we've been working on. We're also working on stuff on ensuring that the health of the OCaml ecosystem is good. So we do a lot of CI work, right?
Right.
All of the packages that you push, we test on variety of platforms, and we're doing all of that work to ensure that the community and the platform and the library ecosystem is stable. Right?
Right.
And we've been doing work on OCaml.org, and we are pushing lots of new stuff there. I mean, you'll see a lot of new documentation, and the website has been rebuilt. And I think that's the sort of focus that we've been working on. We're also working on stuff on ensuring that the health of the OCaml ecosystem is good. So we do a lot of CI work, right? All of the packages that you push, we test on variety of platforms, and we're doing all of that work to ensure that the community and the platform and the library ecosystem is stable. Right? And we've been doing work on OCaml.org, and we are pushing lots of new stuff there. I mean, you'll see a lot of new documentation, and I mean, essentially, I mean, the whole of Tardis is pushing towards OCaml being a nice language for doing stuff, right?
Right.
I want to make OCaml boring, right? I don't want this to be exciting. It
Right.
needs to be boring. It needs to
Right.
just work, right? You shouldn't have conversations about OCaml. You should have conversations about your business, right? And OCaml as a language lets you do that. You just build stuff, right? You don't build with your fancy double filter optics thing, right? It's
Right.
like, hey, I'm just going to write this thing which talks to a network endpoint, and it's going to spin up the service, right? Um,
Right.
yeah,
Right.
so
Yeah.
that's
Yeah. Yeah.
that's where we want to
I
be.
yeah. I think that's kind of like there is this idea where when you are passionate about a language, you are kind of like an early adopter of the language. You become this annoying person on your company where you say all the time, "Oh, in OCaml that would be so much easier." But you are writing, I don't know, something else, some other language, doesn't matter. But then you become the annoying person that you might be eventually right, but your company would hate OCaml just because you become so passionate about it. And
Yeah,
this character, this kind of like persona, is always like on the edge. So it's always like if Rust, it's on Rust. If Zik appears, it's on Zik. Like it's always like surfing all the trends because they kind of value what they couldn't do before or whatever. And then there's the other persona, the other developer with where they are like, I'm using whatever tool like the company wants me to do. Like I'm
yeah,
using Java, PHP, like
yeah.
whatever's on there, and I'm not only gonna use it once everybody is using it, not because there's effects or there's multicore. So yeah, there's this concept of the language can be a tribe or a product,
Hmm.
right? I think
Hmm.
that dance is very curious in OCaml because you want both, and you have both. There's industrial and there's academics, for sure,
Hmm.
for sure. Just okay. Promise. Last question. Just to mention ReasonML. ReasonML can kind of was the a big effort on lowering the barrier on the syntax level only to get people
Hmm.
to try more OCaml. That got merged into
Hmm.
Bucket script or whatever.
Hmm.
But how do you see this effort being realistic? Is syntax a barrier, um, or not really?
Um, I mean, you're asking the bad person because in my first lecture, I would say my students come from learning C++ and Java,
Right.
right? In my first lecture, I would say in this class we don't complain about syntax, uh,
That
right?
that's
So,
a that's a warning. That's a warning that I heard a lot of teachers when they teach OCaml. I think that's kind of the first. Right.
but I totally understand. I mean, these are things which I don't have good intuition towards. I mean, I'm probably familiar with OCaml syntax, so I'm happy programming with it.
Right.
But I see that there is a lot of value in having syntax that is familiar,
Right.
right? And if you want to attract people who are used to other systems and you want to get them over, if syntax is the barrier, I mean that's the least thing that we can
Exactly.
fix, right? That's like nothing. You just fix the
Yep.
syntax, and there's all this beautiful thing that's sitting underneath. And if that's the gateway drug for them to start using OCaml, I think let's let it be, right? So
Right.
um, it's surprising how these things work. I was surprised by how many people got onto using OCaml through Reason and BuckleScript and Rescript and all of these
Right.
different efforts. Right? It's very healthy. I think it's a good thing to happen to the language. I think the core of OCaml is very nice, and more people starting to use it and seeing the benefits. It's a good thing for the world, right?
Right.
At the end of the day, people end up building better software, right? That is what
Right.
we want. And
Yeah, that's
yeah,
that's very good. That's very good, very good. Thank you, Casey. I think we're running very late on your schedule, but and I think it's very late for you. So thank you to staying late and to come to the show. Was a pleasure to meet you, and was a pleasure to spam a few questions. yeah, thank you to be here.
Yeah, it was quite enjoyable. Thanks for hosting me here and yeah, letting me on the show and like pontificate about OCaml. I didn't. I hope I didn't become that annoying OCaml person.
No, I think it's a safe space. Like you here we can pump up OCaml a little bit.
Wonderful. All right. Thank you, Dave.
Yeah, thank you. So yeah, just I'm gonna remove him for a second. So yeah, thanks everybody who is in the chat. I think that was a lovely conversation. I think meeting KC, it's a milestone for the show. So I'm gonna upload this video and this interview to YouTube, and we can share it asynchronous to everybody. So thanks everybody to come. See you next time. Bye.